This meeting is being recorded.
Hi, everyone. We're group 6. We created a restaurant finder. We implemented with Couchbase. I'm Abigail Bhakta.
I'm Bhakti Shetty.
Hi everyone, this is Prakhar Gupta.
And we have Urjita in our group as well.
So our agenda today is going to be a quick introduction, some of Couchbase's features, Couchbase versus RDBMS, our queries, transaction management and security, a restaurant finder overview, our demos and application description, some assumptions, and finally our references. So Couchbase, originally called Membase, is an open source distributed NoSQL database. The data is stored in documents consisting of key value pairs. It's an interactive application within Couchbase that helps multiple users to concurrently create, insert, and modify and share data easily. It is intended to be clustered from a single machine to very large-scale deployments that can span many machines. The applications are designed to provide high throughput for building scalable applications. Some of its features are that it is a NoSQL document-based database. It uses M1QL for query processing. It follows ACID properties for transactions. It's fully integrated with popular languages such as Python and Java. It's a distributed system where various nodes can concurrently work on a database. And its replication system ensures availability at all times.
Moving on to data storage. Couchbase uses buckets, which are fundamental space used for data storage within Couchbase. There are two types of buckets. Couchbase buckets store data in both disk and memory, but ephemeral data only stores the data in memory. As Abigail mentioned, data are stored as documents of key pair values. These data can support complex structures, unlike RDBMS. Within Couchbase, we can have maximum of 30 buckets per node. Each bucket consists of collections and scopes. A collection is similar to table in RDBMS, wherein logically similar data are stored within a collection, and scopes are mechanism used to group different collections. Couchbase allows up to 1,000 scopes to be created within a node. Moving on to indexing, there are two phases that happens within the indexing. There is an index creation phase. In this particular phase, it supports services such as user input validation, host node for an index, and creating index on metadata of host node. We cannot proceed to index build phase until and unless we have completed the index creation phase. There are different types of indices that are supported by Couchbase. There is a primary index, which is created by default, even if the user chooses not to have an index. The primary index consists of a unique UUID. Apart from primary index, it also consists of global secondary index. You can have as many GSIs as you would like. Apart from GSI, there is composite index, which allows you to have two or more columns as an index. And there is a functional index, which is used to store strings in documents as an upper or lowercase string. Couchbase also has an index advisor, which is used for recommending indexes, but it does not guarantee an optimal selection of indexes. It's just a feature which can be utilized for recommending indexes. Moving on to the comparison between Couchbase and RDBMS, which will be explained by Urjita.
Thank you. So the Couchbase is essentially used for document-based databases like JSON. rather than RDBMS. The advantage of Couchbase is that it has dynamic schemas. So even if we change one of the properties in the files, it does not impact, or we do not necessarily need to change other records already present. Also, it's horizontally scalable, which means that we can add new nodes and can effectively distribute the load. It uses the N1 query language, which is similar to SQL, which makes it easier for us to filter the data. And Couchbase is also one of the fastest databases.
So moving on, one of the most important key feature of a database, and especially with any document-based database or a key value database, is storing data. And Couchbase provides us with a unique function, which is different from a lot of databases, where we use something known as upsert. So basically, since earlier we talked about how Couchbase uses a key value pair to store the data, so Couchbase uses this function or a functionality known as upsert to both insert and update a data. So if the data is already present in my Couchbase bucket, then the data is updated if that key is already present. Otherwise, if the key is absent, a new record is created. So you can see that in this code given below, we are connecting to the database first using the credentials, going to the bucket, and also connecting to a Couchbase cluster, which is the local cluster, because our Couchbase is running on local server, and we are just upserting our data, which is our Yelp data, which we are using for our application development. Moving on to the query of N1QL. So N1QL is very similar to SQL. So N1QL uses something known as uh, the N1QL query language, and what it gives us is that it is similar to SQL, but it provides a very similar functionality to a MongoDB type aggregation pipeline. Here you can see that the query is being displayed as a table, and the data which we are using is in form of a document base, and since Couchbase is a document based database, so Urjita would explain the next part.
So N1 query language is similar to SQL. Um, it has two modes like data definition and data manipulation language. It also has statements, expressions, and comments as similar to SQL. And as we see here, we have filtered the data based on category and city. We can see the results as shown below. The query execution plan would be explained by Abigail.
All right, so this is a query execution plan. Couchbase has this great feature where you can see how a query is broken down. And as we can see here, it goes about the best way of finding a query, and it's put an index on the city. And we can see that in the results area as well. Transaction management. So Couchbase follows ACID properties. So in case of a failure, changes are always rolled back. A commit is performed on isolation levels, and automacy and durability are binary properties.
Moving on to security support, Couchbase provides a variety of security protocols that can be executed by the developer as per their need. So some of the topics that are covered are authentication, authorization, auditing, and encryption. For authorization, Couchbase uses the TLS and SCRAM protocols. It also ensures the privacy of data by encoding the data that is stored. And to prevent vulnerabilities such as SQL injection, there are prepared statements which prevent this from happening. We actually experimented with this and found that it's very difficult to perform an SQL injection within Couchbase.
Moving on to our application, we have built a restaurant finder, and the overview of the whole application is in a way that we have built this application using Flask, which is a Python based framework, web framework, and that takes care of our UI. since we were already using a Python-based framework, we decided to stick with Python for coding, taking care of our backend. So our backend is responsible for querying our data, creating prepared statement, and firing them to the Couchbase server. So user can filter restaurants based on city, cuisine, Wi-Fi, and other attributes to find their respective restaurants. So moving on to the demo. So let me just restart the server.
And so here's the website. As we see, here is the website, which is connected to the which is deployed on the local host and connected to the Flask. This website has services. When we click on the services, it displays a form, which gives us an idea what we are looking for and how it would be displayed. This form is actually a required form, like as in all fields of this form are mandatory. Also on the top of this, we have some cuisines, which you can take a look offered at many restaurants. We can fill the form and see how it goes.
Yeah. So for the form, we have stick to 4 cities. In our data, we had 5,000 cities, but for the demo purposes, we are sticking to the 4 cities. So for the demo, let's search for a place in Philadelphia. Let's choose an Italian place because I love Italian food. Let's check for a trendy place. Let's see, we want a full bar, and let's say we go for a non-children friendly place. Reservation, yeah, I want to have a reservation beforehand, and yeah, everyone loves free Wi-Fi. So yeah, so the Flask sent a request to the Python backend, and the Python backend sent the prepared statement to the Couchbase server, and the Couchbase server returned the response, and which was reciprocated back to the Flask, which displayed it on the UI. So here you can see example, which is a restaurant route, and it's in 1206 Frankfurt Avenue, and you can see the city is Philadelphia. The cuisines listed here are Italian, and it has other stuff like Spanish, and it offers things like an American cuisine as well. Yep, it requires a prior reservation. It isn't children friendly. Yeah, there is a free Wi-Fi. As you can see, the alcohol is served over here, and it's a full bar, and the ambience is classy and trendy. And so our restaurants are listed based on the number of stars they get, as well as the number of reviews. So they are listed in descending order so that we showcase the best restaurant to our user. So moving on, how we do it at how does we do it in the backend. You can see this is the Flask code, which is responsible for rendering the UI. And if we go to the function create query, here we have all the connection and all the backend stuff, through which we connect it with to the Couchbase server. So you can see that we enter the username, password, bucket name, which is Yelp, as we are using the Yelp data. We authenticate our service, then we connect it to the Couchbase server, which is running on localhost, and we go into the collection, which is the collection in the bucket, which was Yelp, and the collection is called data. And here we have created something which we talked about, which is called prepared statements. So you can create prepared statement using query option and passing positional parameters to it. So here you can see the parameter list is there, and here you can see the $sign with the number, which showcase which parameter the Couchbase needs to add it to the query. So we realized that Couchbase was performing really good when it comes to equal queries where it need to perform an equality search. But when we were trying to do it with the like statement, this positional parameter and prepared statement was not giving us consistent results. So we decided to use strings and append those strings to create this query. After we receive the results, we are processing them using this function, which is JSON, process JSON, through which we replace all our inconsistencies, and after which we just display it back on the UI, which you can see here. So yeah, moving on to the assumptions which we made. So one of the assumptions was that all the data which we use, we have assumed that it's accurate. And if we get a record for a restaurant in Philadelphia, we are assuming that it's accurate and the data is correct and it contains accurate values. And secondly, the demo is a proof of concept, and it's over which multi-layered applications can be built on. So yeah, so here are our references. So we have referred to Couchbase documentation a lot to build our application and to understand how Couchbase work. And there is also multiple articles which we went through. So yeah, thank you all.